on this computer. Okay. We are now recording. And now let me get my screen back correctly. I'm going to be showing this, so I'll put this here. Okay. Hang on, folks. I got to get this set up right, and then we'll get started. All right. All right, this is the first time I've tried to do this, so share my screen. All right, so can you all see my IntelliJ screen?
Yeah.
Yes, Bill.
Okay. And now I actually have to, where's, gee, I have an agenda tonight and everything, but I'm having difficulties getting set up. Okay. So, well, where is everything? Oh, there it is over there. Here's what I want to do. Here is the chapter 8 problem. Everybody see that?
Yes.
We are going to talk about graphs this week. This is an example of a graph. It is basically a network, and it consists of vertices, which are the circles in this picture, and edges. And an edge consists of two vertices and a weight. That is either the distance from one vertex to the next, or the time it takes to go that distance, or the cost of going from vertex A to B, etc. And so in a program, a vertex is going to be an object, and it's basically going to contain a name And in this case, in our assignment, it's going to be some city names, as a matter of fact. The edge is going to consist of a source city and a destination city, and then a weight, which is the number in between. So, and the graph is the collection of edges and vertexes, or vertices. We're going to be using an algorithm called Dijkstra's algorithm. Dijkstra was a computer scientist back, I think, in the 60s, and he was, I think, from Denmark, and he did a whole lot of different things in computer science, but the algorithm that bears his name basically finds the shortest path through a graph. And I think we should watch this this video, and if you haven't already, and because it explains it pretty well. If we can get some sound. Well, great. No sound. Why don't we get sound? Well, forget that. Everybody can look at that themselves. Basically, what you're going to do in this problem, so let's look down here at the problem, the assignment. This is the graph with cities, and graphs can be directed or undirected. In our case, they're going to be directed, and that's what is meant by these arrowheads. This edge says that there is a connection from El Paso to Austin, and this one also happens to have a return edge back to El Paso. But Billings has a path from Austin, but not one back to Austin. So if you're in Billings and you want to go to Austin, you're going to have to go to Chicago and then back to Austin, because this edge right here is directed. So you're going to have 3 files, which we'll look at in a minute, are Java files, edge and vertex and graph. Okay, and then I'm going to give you, and then you're going to have a domain class called requested record and one called input record. The input record is the flight data, which gives you all of these connections between cities and the cost and the time that it takes to go between those two cities. The requested record are that was not what I wanted to do. The requested record is what we're trying to solve in the problem. Is we want to find the shortest distance between Chicago and Austin. So what's the best connection for the shortest distance, or the shortest time, or the shortest cost? So here is an example of the flight data. It shows the source, Dallas to Austin, and that says, I think, 98 miles and costs $47, I think is the way I read that. And the number at the beginning is the number of records in the file. Now, in the lesson 6, we learned how to use the stream with the lines method and the path.get method, and reading a file into a data structure. I would like for you to use that again. So what you can do is one record in that stream. And that's going to get rid of the number in front. And so you'll just read the records in the file until it runs out of records, just like we did in lesson 6. The requested flight plans, if, for instance, I will ask, I'll give you a file that says, I want to go from Dallas to Houston. What is the most direct flight time-wise? Or we might want to go from Chicago to Dallas, and what's the minimum cost? Okay, and then your output is going to be like this. For this first flight from Dallas to Houston, based on time, you're going to find up to 3 different paths between these 2 cities. And the first path goes Dallas to Houston, in time is 51 and the cost is $101. And path 2 is Dallas to Austin to Houston, and the total time is 86 minutes and the cost is $193. So this is the type of output that you're going to generate from this program. So let's go back to the code. Here is the vertex, and I was working with this when time arrived, and so I was having some issues, but anyhow, we'll get around those. A vertex contains nothing but the name, the city name, and again, I'm using Lombok in this problem. Then we're going, here's an edge. An edge consists of an ID, and that ID, you can just use the 2 city names like Dallas as space and a dash and a greater than symbol for an arrow, and Houston. And that would be what the ID would be, just a string which you can print out as what this edge represents. And then of course it has a source vertex and a destination vertex, and then it has a weight value. And that weight is just a number. It can be whatever you want it to be. Then the graph here, the graph consists of a list of vertices and a list of edges. Okay, so when you create a graph, you have to pass it the vertices and the edges. Now there's the flight data. There's the requested flights that you can download. The input record, I have a class for that, and that's the way that you create an edge. Actually, you're going to create 2 lists of edges. You'll notice that the input record has a cost and a time for this connection. So you're going to create a record in one list that is the cost, and you're going to create an entry in a separate list, another edge that represents the time. So you'll have 2 different lists, one for cost, one for time. But the input record contains them both. And then the requested record data is here. It has from and a to, and the stipulation is whether it's a cost or time, C or T. Let's close this one. So here is Dijkstra's algorithm. I downloaded this off the internet, last year tutoring a student, and it worked so very well that I'm using it again. And I'll probably made some improvements along the way, but basically this is the algorithm that I found on the internet. The constructor takes in a graph, and you'll pass it a graph containing the vertices and either the cost set of edges or the time set of edges based upon what the request says. And you'll create a graph, and then you'll pass that graph into and create a Dijkstra algorithm object. You'll create one Dijkstra algorithm object for each of the requests. So then it has an execute method, which takes in the source vertex, and it initializes a bunch of stuff. There's settled nodes, unsettled nodes, distance predecessors, distance, unsettled nodes, and then he loads those. And basically, this is creating the, if you look at that video, that 3-minute video that I was going to show you, but it couldn't get the sound to play. That's what it's doing here. Only in the video, he's doing it with pencil and paper. This routine is creating that information. It's creating the total time or the total weights from the source to, I think, every target, basically. And then down here, then you're going to call the find minimal distances with a node. This is the okay, that's just used by that method there. You will not use this one. It's a private method. And then there's another private method. Where's the, okay, here's the other public method. After you've called it with the first you'll pass in the source, and then you will call this method, get path, which says give me the shortest path from the source that I've already given you to this target, and return me a list of vertices. And that's what this does. So in the main, you're going to first read the flight data. You skip the first record. You're going to use the lines and the path.get like we did last time. You'll split the records on a comma. You'll create a new input record object. And for each input record, then you'll add it to the input rec list in your main program. And you'll add the source to the vertex list if it's not already stored there. Then you're going to do, after all the flight data is read and stored, you're going to iterate through those at list and create a cost edge and a time edge for each pair of sources and targets. So you're going to create all those, the list of cost edges and the list of time edges. But at that point in time, you're ready to read the requested flights. And basically, you'll use the line stop path, you'll split them on a comma, you'll create a new request and add it to a request list. And you got all the data read in at that time. So the next thing, why don't I just show you these notes rather than read them to you. If I can get to them. Okay, these are the notes I'm reading. So after you've read in the flight data and you've created the vertices list and the edges for cost and the edges for time, you'll be reading in the request flights data and storing them in a list. And now you want to make a copy of the cost and time lists, edge list, because you'll be modifying them during the process, and so each time for each request you'll want to reset them. So then you will, for each request, you're going to find 3 paths between the departure and destination cities by creating a draft using the nodes list and the appropriate edge list based upon what the request asks. Does it want to know the paths with the least cost or the paths with the least time? So then you'll create a new Dijkstra algorithm object with that created graph. Then you'll call the Dijkstra algorithm execute method using the source node. And then you'll call the Dijkstra get path method using the target node, and that will return a list of vertexes representing the shortest path through the graph. Okay, now you're gonna, okay, scroll up. You're gonna traverse that list of vertices, that path that came back, and you accumulate the time and cost, printing the path as you go and the total time or cost when the target vertex is reached. Okay, you'll add the weight in that path to the time or cost, because you're only interested in one of them, I think. But you'll accumulate those as you go, as you go through the path. And hint, you'll have to remove that edge from the path after accumulating it. The reason of that is that if you don't, you'll end up putting out 3 copies of the same path. Path. So you're going to have to remove those vertices as you accumulate them, so that you get unique paths. And you'll also want to be aware that either the source or the destination may not be in your vertices. Some of the data, all the data is not there. And also, the Dijkstra algorithm may return say there's no path through the graph for that source and target. And you also may only have 1 path, or you may have 2 paths, or you may have all 3 paths. So you got to allow for all those different conditions. And let's see, is there more to this? No, I guess that's the bottom. Well, so so for each path, you're going to accumulate the time and the cost. Interesting.
Right.
Okay, as you pull back the paths, the edges from the paths, you can look the well, okay, I'm going to show this quick. Here's you're reading in the flight data, and for each input record, you're going to add it to an input rec list, and then you're going to add that vertex to the set of nodes, just the source. Okay, and then for each input record, you're going to create a set of edges, and the IDs will be the source and an arrow and the target. The source will be the vertex of the source. The second will be the vertex of the target, and then the cost. And that goes into one list, the edges for cost, edges for time. And then you got to save those, as I said. Then you have to read in the request data and store it in a list of requests. So now for each request, you're going to retrieve the from and the to and the cost or time, and you're going to print out the line that says this flight number, and you're going to have a source and a target and what you requested. And then you're going to restore the edges back that you saved up above, and then too fast. You're going to create a Dijkstra algorithm. Well, that just declares it. So if the node contains the source, okay, yeah. So here's it defines the graph. It's going to create the appropriate graph from the edge cost or the edge time. You're going to create a new Dijkstra algorithm on that graph. Then you're going to call the execute method with the source vertex. You're going to zero the total cost and time. Then you're going to say, give me the path through that with that target. And if the path is not equal null or empty, then you're going to print out the path, and you're going to go through that path. You're going to retrieve each entry from the path, and if it's equal to the target, then you're going to print out the total time and total cost. Else, if it's not the target yet, you're going to accumulate the time and cost for that edge, using it from both the edges and time and cost. And that routine is right here. It says set up the ID, source to target, and then it calls total or sum and remove edge for the edge's time. And here's the sum and remove edge. It goes through the edges list, and it gets the weight and sums it and removes that edge at that time. And after you go through all the edges in that list, you return the sum. And that gets put in the total time. And then you do the same thing with the costs and put in there. And then you come back up here and you print that stuff out. And if in a zero, you'll say there's no connection. That just say Dijkstra didn't find a connection between those two. And that's the whole main. But the main thing that I want you to get is these notes, where my notes are. And I can put this recording and I can put these notes out there for you, along with the assignment that's already out there, the stuff that's already out there. So this is a
internet issue.
I'm sorry?
Yes, if you can please get a recorder and your note, because my internet I have trouble with internet. I disconnected for 2 times.
Okay. Well, I'll put the recording and I'll put these notes out there along with the assignment,
Okay, thank you
so
so
that
much.
you can all get it, and those who cannot attend this evening can also get them.
Yeah, thank you.
All right, thanks.
Any questions?
Not right now. I haven't read through and watched the videos yet, so.
And Professor Fly, am I right in seeing that you haven't uploaded those files yet? Because I don't see them, so the files we're going to need?
Well, I haven't put the notes and I
Okay.
haven't put the recording up there, no. But I
No,
have, here's the Java files that I am providing you.
I don't see those. Why can't I see those? All right, I'm going to go out and go back in.
Well, can y'all not see lesson 5?
I can see lesson 5. I can see the graph. I can see the 3-minute video. And then I see graph data structure 1 terminology and representation video. And then I see the Dijkstra's algorithm, and I see the link for the quiz. That's all I see.
That's
All
the
right,
same
just a
here.
moment.
Yeah, same here.
Okay. Let's, due date 9:30. That's not right. That was yesterday. The due date is going to be the 7th. And make the assignment available. There's what's not there. Sorry, guys.
You were just trying to give us heart failure.
I know. Well, you know, I made a decision last weekend to go on and do 6 and then come back to 5, and that caused a lot of problems. So hopefully you can now see.
I see them now. They're there.
Okay, so here are the Java files. I will add the recording and my notes out there. And again, here is an example of the input. And here's the requests. And here's what I'm looking for in the output.
Okay.
Or this would be the printed output for, you know, this data.
Okay.
Any other questions?
Not yet, but I have a feeling we'll have a lot more. Are we still having our conference on Friday? I mean, Saturday morning?
Yes.
Okay.
But I knew that this problem was not crystal clear, obvious. So I wanted to have an early conference to give you a kind of a head start, and so now you can go off and the other thing that I recommend is let's use some additional packages under EDU DCCD. Put a Dijkstra package, put the Dijkstra algorithm in that package. Create a sub package called graph and put the edge, the graph, and the vertex methods in it. And then put a package out there called Lesson5 and put the input record and the main and the requested record in it.
Okay.
We need to start separating our classes into separate sub packages to keep them separated and well, like when we get to spring, for instance, you're going to have a sub package for the model. You're going to have a sub package for your controllers. You're going to have a sub package for your views. So I just want you to get used to putting things in different packages, sub packages, and see the graph is in EDU DCCD graph. The requested record is in EDU DCCD lesson 5. So separate these out, and I'll make a note of that in my notes. to separate those into different subpaths.
Are we using the Maven template again
Yes.
too? Okay.
Yes. I would recommend using that every time because you're using Lombok. So
Okay.
just use the Maven template to start your project off, and that should make things easier for you. Questions?
Not so far.
All
Not
right.
yet.
All right, guys. Well, I'm available by email anytime.
All right. Thank you.
Thank
All
you,
right.
Professor Fly.
You're welcome.
Thank you so much.
Mm.